morning, dear children. This is MP Gupta from Kendriya Vidyalaya, Lonavala. Today I am going to discuss the remaining part of the D and F block element. I have already discussed the first part, that is up to the preparation of potassium dichromate. I will discuss today the remaining part of this chapter. First, the preparation of potassium permanganate. KMnO4, preparation of KMnO4. How it is prepared? There are two methods. First, by fusion with the alkali metal hydroxide in presence of air. The manganese dioxide is fused with the potassium hydroxide in presence of KNO3 to produce the oxygen. That is, in the presence of oxygen, manganese dioxide MnO2, potassium hydroxide KOH, and oxygen, it get converted into potassium magnate K2MnO4 H2O. To balance, write the balanced equation. 2 will be 4 here 2. This potassium magnate is filtered off, then it is hydrolyzed with the acid to convert into the magnate, potassium permanganate. Potassium permanganate KMnO4 is prepared by fusion of manganese dioxide with potassium hydroxide in presence of air. First it is converted into potassium magnate, then potassium magnate is hydrolyzed with the sulfuric acid to give potassium permanganate. This one is the ionic equation. Magnate ion is converted into permanganate. The second method, that is a commercial method, commercial preparation of KMnO4. Here again it is also prepared by the fusion of manganese dioxide with potassium hydroxide to get potassium magnate. The first step is the same. To K2MnO4 plus 4H2O. Then magnate ion is electrolyzed, that is on electrolytic reduction. It on electrolytic reduction produce permanganate ion. So commercially, the potassium permanganate is prepared by fusion of manganese dioxide with potassium hydroxide in presence of air to get potassium magnate. Then potassium magnate is electrolytically reduced. On electrolytic reduction, it gave potassium permanganate. So these two methods, we have to know only the reaction, because in the examination, sometimes question can be asked, write the reaction involved for the preparation of potassium permanganate. Now its chemical property. Now the chemical properties of potassium permanganate. Potassium permanganate is a strong oxidizing agent in acidic, neutral and basic medium. First, I am discussing here the oxidizing property of potassium permanganate in acidic medium. Potassium permanganate KMnO4, we just take its ionic reaction. Permanganate ion is converted into Mn plus 2. Here the oxidation state of Mn is 2 4 8 minus 1, that is plus 7, plus 7 to plus 2, it gets reduced. So how can we write its the equation, ionic equation? 4 oxygen in acidic medium, that will be 4H2O, then balance hydrogen, 4 into 2, 8, put here 8 hydrogen ion, then balance the electron, total number of electron here, plus 7 this side, plus 8 minus 1 plus 7, this side plus 2, so we add 5 electron. If you know this ionic reaction, this one, we can easily write the oxidizing property of potassium permanganate in acidic medium. For example, here are certain reaction. Number 1, it oxidizes oxalic acid into carbon dioxide. This we do in the practical volumetric analysis, titration of potassium permanganate with oxalic acid. Then how can you learn this reaction easily? First, balance carbon 2, it means we have to know, first we have to know what products are formed. Oxalic acid is converted into carbon dioxide. This we keep in our mind, oxalic acid converted to carbon dioxide. Then write this reaction, see here 2 hydrogen, put here 2H plus, then balance the electron. This side there is no electron, this side there is 2 plus plus charge, so it can be balanced by adding 2 electron. This ionic reaction, if you know this ionic reaction, then first we have to know this one for all the oxidizing property of potassium permanganate in acidic medium. Second one for particular reaction, this one. So if the question is asked, write the ionic equation or write the reaction, or what happens when potassium permanganate is treated with the oxalic acid. So we can write the ionic equation. There is no need to write the complete equation. So how can we write this reaction? First this one, second this one. We add first and second. Then what will be the equation? Here is 5 electron, 2 electron. These two can be balanced by multiplying here 2, this one by 5. Then multiply this equation by 2 and this equation by 5 and add the equation. That will be the final answer. That is 2MnO4, 16H plus, 10 electron, 5H2C2 oxalic acid. Then right side 2 Mn 2 plus 8 H2O, then 10 CO2, 5 into 2 10 H plus, then 10 electron. Cancel the electron, 10 electron get cancelled. Here 16 H plus, 10 H plus, overall here will be 6 H plus. The final equation will be 2 MnO4 plus 6 H plus 5 H2C2O4, 2 Mn 2 plus 8 H2O and 10 CO2. This is cancelled. We write here 6. This is the equation. So instead learning this equation, better to learn this equation. This is common for all the oxidizing property of KMnO4 in acidic medium. Then learn particular reaction. There are other reaction. For example, potassium permanganate oxidize iodide ion into iodine. Second one, sulfur dioxide into sulfate ion. Third, sulfide ion into sulfate ion. Then hydrogen sulfide into sulfur. How can you write this valence equation? For example, this is common. for all these reactions. Try to balance it. First, here is 2, put here 2, 2 minus, so balance the electron, 2 negative charge, 2 into 1. It can be balanced by adding 2 electron. So this is the balance equation. Then this is common, first one, it is common for all, first, this will be this reaction. So add these two, this one, like here. So this can be balanced if you write first equation this, second equation this, then try to balance the electron. First balance the electron. Here are 5 electron, 2 electron. So multiply this equation by 5, this equation by 2 and add together. We get just like this 2 equation here. Similarly for this one. So second case, in case of sulfur dioxide, first balance this equation. Here is oxygen 2, 4, balance it by adding here 2 H2O, because 2 oxygen, 4 oxygen. Oxygen balance by adding water, 2 molecules of water, then balance hydrogen and 2 into 2, 4, put here 4 hydrogen and 4 H plus, then balance the charge, total charge plus 4 minus 2, that is plus 2, here is this side plus 2 charge is extra, so this charge can be balanced by adding 2 electron. Similarly, this is the case, suppose the question is asked, what happens when potassium permanganate react with the sulfur dioxide. So this one, this is the reaction, first reaction this, second reaction this one, then balance these two like these, here multiplied by 2, this is 2 electron, in this case there are 5 electron. This 5 electron and 2 electrons are balanced by multiplying this equation by 2 and multiply this equation by 5, then add together, that will be the answer. Similarly, in case of sulfite ion, then sulfite ion is converted into sulfate ion, the same way balance first oxygen, sulfur is already 1, no need to balance it. 3 oxygen, 4 oxygen, it is balanced by adding for 1 oxygen, 1 water molecule, H2O. Then balance hydrogen, here is 2 hydrogen, so add opposite side 2 hydrogen ion, then balance the charge. These 2 negative and 2 negative get cancelled, here is 2 plus charge, 2 into 1, 2 plus charge, this is balanced by adding 2 electron, so add here 2 electron. Same way, just I told in above 3, like for this one and this one, again this equation can be written in ionic equation. There is no need to write the complete equation in the exam. If the question is asked, what happens when particular sulfide reacts with the potassium permanganate in acidic medium, or particular iodide reacts with the potassium permanganate in acidic medium, then write only the ionic equation. Generally one question, definitely it can be asked from this area, either from potassium permanganate or from the potassium dichromate. Again, just I told you, first you write this ionic equation, second this equation, first see balance the charge, balance the electron, here 5 electron, here is 2 electron, then balance the electron, 2 and 5 can be balanced by multiplying this equation by 2 like this and multiply this equation by 5, because here is 5 electron, 2 electron, and then add together. That will be the final answer. Dear children, as we have finished the D block elements, now come on the F block elements. First, here is the general outline of modern periodic table to show the F block elements. S block, D block, P block. Here are 2 lines. These are the elements of F block. Actually, these F block elements are here in 6th period, 3rd group, Lanthanides, atomic number 57. From 57 to 71, that is, these are the Lanthanides. These elements are known as Lanthanides. These are kept here, all these elements are kept here from 57 to 71. The elements are lanthanide, cerium, praseodymium, neodymium, promethium, samarium, europium, gadolinium, terbium, dihorium, holmium, europium, thulium, ytterbium and lutetium. These all elements are known as lanthanides. And other series in period 7, third group, atomic number 89 to 103, all these elements are kept here. These are known as actinides: actinium, thorium, protactinium, uranium, neptunium, plutonium, americium, curium, berkelium, californium, einsteinium, fermium, mendelevium, nobelium and lawrencium. These elements are known as actinides. Now the properties of lanthanides and actinides. Since most of the elements are radioactive, their chemistry are very less known. I am going to describe here the comparative properties, some few properties of the lanthanide and actinides. First, the electronic configuration. It's a general electronic configuration, that is xenon, noble gas, 4F 0 to 14, 5D 1 to 6S 2. And the electronic configuration of actinides are: after radon 5F 0 to 14, 6D 1 2 and 7S 2. Second one, the oxidation state. The common oxidation state of lanthanides are +3, but in few cases it is found +2 and +4 also. +3, +4, +5, +6, +7. Then atomic and ionic size. Atomic size and ionic radii. There is gradual decrease in the atomic size and ionic radii also. This is due to the lanthanide contraction. The size decreases, gradual decrease in size, due to lanthanide contraction. I have already discussed about the what are lanthanide contraction.